In this topic, you will learn how to determine the value of a function when its variable approaches a certain value. So let's say that x is the variable of the function fx. When x is approaching a certain value of a, your fx will approach a certain value of k. Okay, so then we will say that the limit to the value of the function fx is k. This result can be written as limit of fx when x approaching a is k. So this is the concept of the function of fx where the variable is approaching a certain number. So let's see an example. For example, as x approaching infinity, fx, let's say the function of fx is 1 over x to the power of 2. So in this example, you want to see the value of x when x is approaching infinity. Infinity represents a value that is so large that it is undefined. So I would tabulate a table. For example, this is x and this is fx, which is 1 to the 2 over x to the power of 2. Okay, I am tabulating the value, a table for this question. So when I put x as 1, replace x to 1 into the function, you will get 1 over 1 to the power of 2. 1. Then keep tabulating 2 as x, so 1 over 2 to the power of 2, you get 0.25. So keep tabulating 3, 4, 5 until the value of 1000. You don't have to do it one by one, but this is just to prove that how the concept works. So when you put 1000 into x, 1 over 1000 to the power of 2, you will get 0. 0.00001, which means the larger the value of x, you notice that fx is approaching 0. Okay, so what if when you say infinity, if you say when x is approaching infinity, definitely fx will be 0. Okay, so in this case we can write, okay, for this example, you can write limit of x approaching infinity for function of limit of fx when x approaching infinity, you will get 0. Or you can just replace fx as 1 over x to the power of 2 is 0. So this concept of function will be used to answer the questions involving limits in this chapter. Okay, let's see an example using the function limit of function that we have learned before. So let's say limit of x approaching infinity, limit of 2x to the power of 2 plus 1 over x to the power of 2. So find the limit of this function when x is approaching infinity. So in this question, the functions given are called as improper fractions. So to determine the limits, we have to first express them in the form of a proper functions. So in A, we know that from our previous example, you can use that as our guideline. You know that limit of 1 over x to the power of 2 when x approaching infinity is always 0. So using this concept, try to solve this question. Okay, so first write down the concept and then create a proper fractions from the fractions given. So 2x to the power of 2 over x to the power of 2, you will get, okay, I'm going to write down the proper fractions of this question. So 2x to the power of 2 over x to the power of 2, you will get 2, correct? Plus 1 over x to the power of 2. 1 over x to the power of 2. So the answer would be, when x approaching infinity is 0, so this will be 0. Write down 2 because there is no x in it, so you can just write down 2 here. 1 to the power over x to the power of 2, the limit of x approaching infinity for 1 to the power 1 over x to the power of 2 is 0. So 0 here. So you get 2. Okay, that is one question answered. Now let's see another question. I would say a difficult one. So the limit of a function 2n to the power of 2 minus 18 over n minus 3 when n is approaching 3. Okay, for this type of question, the method is still the same. What you have to do is to change the improper fractions into a proper fractions. So what I mean from proper fractions is to rewrite the fractions to a simpler form. So take 2 out as factorize the fractions to n to minus 9, correct? 9 times 2 is 18 and 2 times n to the power of 2 is 2n to the power of 2 over n minus 3. Okay, so you want it to be even simpler to understand, so write down 2n to the power of 2 minus 3 to the power of 2. So you will get n to the power of 2 minus 3 to the power of 2, which is similar to the below equation. And then you can rewrite it again to be n minus 3 plus times n plus 3. So always remember that when you have such a equation, n to the power of 2 minus 3 to the power of 2, it will eventually give us n minus 3 times n plus 3. Okay, you can try to solve to prove that these when you multiply both of these equation, you will get n to the power of 2 minus 3 to the power of 2. Okay, so when you see from here, you know that n minus 3 and n minus 3, when you divide both numbers, you will get 1. So alas, you will get n approaching 3 is 2 n plus 3. So this type of question is quite simple. What you have to do is to change the improper fractions into proper fractions and eliminate excessive equations that you don't need. Okay, when you have this simple equation, then you can just put n as 3 plus 3. Okay, so you get 12. The steps is important because these steps will be counted in your examination.